thank you very much, Madam President, Madam Minister, Ambassadors, Excellencies, ladies and gentlemen. It's a real pleasure to have you all here in this room. So the title of my talk is a pompous one, of course, saving the world by construction, but I really mean that, and I will try to explain. But the built environment is really the most important factor in the climate equation, but also in the sustainability equation. So we all refer, and this is a nice picture of Cardinal Turks and myself, because we had the honor to present the encyclical Laudato Si in 2015 to the world public, actually. And it's often overlooked, but within the encyclical, you don't need to read this now, because I will just underline the most important sentence. The paragraphs 44 and 45 in the encyclical are all about the built environment. It's a specific passion of Pope Francis, who was the Archbishop of Buenos Aires and worked a lot in the slums of Buenos Aires. So this is very dear and very near to his heart. I just read out one sentence, the last of the first paragraph. We were not meant to be inundated by cement, asphalt, glass, and metal, and deprived of physical contact with nature. So this is a very, very important sentence in Laudato Si. So as Joachim von Braun has already mentioned, the Academy, the Pontifical Academy of Sciences, was helping to create that encyclical, as was, of course, Cardinal Turkson, and was often consulted in this context. And we had a number of giants, really, and we still have a number of giants in our academy. As Joachim mentioned, 25 Nobel laureates, and two of them, on whose shoulders we all stand, are Mario Molina and Paul Crutzen, dear friends, giants of sciences, and taking along the responsibility you need to take if you are a bit more knowledgeable than other people. They were actually much more knowledgeable than other people. And I had the privilege to write for the Proceeding of the National Academy an obituary for Paul Crutzen, where I also mentioned Mario Molina, and the motto was ingenuousness and innocence, because you learn that these people who know most are also the most humble people. And they created, Paul Crutzen, the notion of the Anthropocene. Actually, it was in a meeting in Cuernavaca in Mexico where we first discussed this a long time ago in the year 2000. So I was in the room, we discussed it, and Paul submitted this in a very humble way. He said, couldn't we even think of calling the current era the Anthropocene? And of course, he was very shy because he thought he would be turned down immediately. But the word started to fly and has created a new thinking, actually. Yeah? So this is the Anthropocene website, for example. One of the outstanding things you will find in the original papers is, but after 1950, after the Second World War, we had this great acceleration. We described it in a paper recently, Emergence and Evolution of Earth System Science. And this is the great acceleration. Whatever factor you look at, whatever dimension, material, energetic, and so on, with its exponential growth after 1950, yeah, of resources, of pollution, of waste, and so on. It is a completely unsustainable world we are living in, but people don't take notice. We call it globalization. It is a very, very harmless notion, so to speak. But behind this globalization is the great acceleration of energetic and material flows. And this will break through all the planetary boundaries we have. So I want to share with you this paper. It was published by a group from Israel, from the Weizmann Institute 2 years ago. And this is really an amazing insight because it compares the living biomass on Earth with the anthropogenic mass, which is, as you can see on the right-hand side, it is concrete, aggregates, bricks, asphalt, metals, plastic, by the way, The contribution is so small that you cannot even see it. It's in yellow here, although everybody talks about plastic. But concrete is the bulk of that. And actually, 2 years ago, we had this crossover that the anthropogenic mass exceeded the living biomass on Earth. Before the Industrial Revolution, it used to be 2 teratons, that is 1,000 billion tons of living biomass. We have reduced that in half actually already. So killed 1 trillion tons of living biomass on Earth, but have replaced it by man-made mass. This is a metabolic transformation of the Earth system. And that's why the Anthropocene is absolutely justified. Actually, the interesting thing is, because when we talk, and also here in the Vatican, when people talk, the problem is overpopulation, for example, growth of human population. Here you see which countries and which regions of the world really contribute to overshooting the capacities of the Earth. And on the right-hand side, you see it's the US since 1970, it's the European Union, including, in spite of the Brexit, the UK here, and the rest of the planet is contributing almost nothing to overshooting the capacities of the planet. So it's our legacy in Europe in particular and in the US to fix this problem. Climate is the most urgent of all problems, but by far not the only one, because biodiversity crisis is just a terrible one, and many other things. Our soils get deprived and degraded and so on. But what you see here on the right-hand side, it's a busy diagram which I personally invented together with Rick Leemans from the Netherlands when we worked for the third assessment report of the IPCC. It's now become known as the burning embers diagram. On the right-hand side, what you see is how much warming, so 1 degree, 1.5, 2, 3 degrees, do we need in order to tip precious elements of the Earth system, like melting the Greenland ice sheet, destroying the Amazon rainforest. And believe it or not, in 2001, when we first published that, the red color, which means we are certain that this extinction will happen, was at 6 degrees warming. So within 20 years, the red color came down to 2 degrees, actually. So you see, we are really heading for the wall right now. And even worse, so we have the climate emergency, even worse, these tipping elements can conspire and can work together in order to move us into a hothouse Earth, actually. So for humankind and our civilization to subsist, it's absolutely crucial that we stay below 2 degrees. But we will not. And that is the sad message I have to tell you. We will overshoot 1.5 degrees and we will overshoot 2 degrees. So the challenge is to come back and to work back 1/10 of a degree by 1/10 of a degree back to something like a safe level, which would be 1.5 degrees in our view. So how can it be done? How can we hold the Paris lines? Now, here are the 3 necessary conditions for that. And the first one is you have to just reduce emissions to 0 by 2050. And we have here Ursula von der Leyen with the Green Deal, which is a major contribution to that. He is having a lot of problems in the European Parliament, of course, right now, as we just discussed. But one element has been passed already. So we have to make Europe, but also the world, climate neutral by 2050. The problem is this is not enough. At the same time, we have to protect the natural common things, which have taken up half of all our emissions. But we are about to kill our best friends like the Amazon rainforest right now. But the third thing is we have to create managed carbon sinks, additional carbon sinks. So how can this be done? Well, the IPCC estimated that a tremendous amount of negative emissions, so-called negative emissions, would come from bioenergy with carbon capture and sequestration. In my view, and I've worked on that quite a bit, it will not actually do the job, because we cannot remove 20, 30 billion tons of CO2 by carbon sequestration, for example. But there's a much better way to do it. We turn to the built environment. I call it often the elephant in the climate room. I had a discussion with Clara Geibitz about that. You can call it the white elephant or the gray elephant or the black elephant, whatever. But it is the elephant. Why? Because about 40% of global emissions come from the built environment by constructing buildings, by operating them, by destroying them, for example, in infrastructures. And in the world, it's more than 55%, or in the developed world, of the waste created. So this is the most important factor in the sustainability equation. But nevertheless, everybody talks about aviation, you know, flight shame and all these things. This is about 2% of the global emissions. What about the 40%? So let's start talking about that. And we do it here, we do it in Germany now, we do it at the European Union. So this is the motto. We have to reforest the planet and retimber the city. We have enough degraded land on this planet, about 1 billion hectares of degraded land, which we could turn into vital ecosystems again, into managed forests and so on. So we did a paper a while ago, Buildings as a Global Carbon Sink, where we calculated, yes, we could take out a lot of the historic emissions by turning to organic architecture. And this would be this forestry construction pump. I will not talk you through this complicated diagram, but it means more or less do sustainable forestry on this planet, reforest degraded land, then take out biomass and turn the harvested biomass into infrastructures and buildings, but replant immediately and recycle the timber, the bamboo, and so on. So you have 2 sub-cycles, and altogether it's the cycle that is actually cleaning the atmosphere from historic emissions. And I give you a few numbers on that because I did a back of the envelope calculation. To restore the climate, so let me tell you, since the Industrial Revolution, at that time, the atmospheric concentration of CO2 was 280 ppm, parts per million. This year we passed 420. So we have added 140 ppm. This corresponds to 1 trillion ton of CO2. That is 50% enrichment of the original level. We could take out this 140 ppm if we would do just the following, just add and support, of course, 500 billion trees. That is 50 trees for every human being. It would cost 500 euros. And build, in the long run, 2 billion homes from harvested biomass. That is equivalent to taking out 140 ppm and bring us back to 208. Now, if we are not successful, because in reality it will never work optimally, if you only achieve half of it, half of 140 is 70. Now, if you subtract from 420, 70, you come up with 350 ppm. And that is considered by the Earth system scientists as the safe limit, actually. So even if only 50% of that would be achieved, we would be at the safe level again. So you see, it's the all crucial element of the climate equation. And it would be just replaying the game nature played 300 billion years ago. In the Carboniferous age, you had this lush vegetation, CO2 level was higher, Earth was warmer, and it was at that time when all the fossil fuels were created. Coal, gas, oil, because it is all biomass, which was transformed by exclusion from oxygen. And at that time, actually, the vegetation extracted a huge amount of CO2 from the atmosphere. And if it would have gone on for another 2 or 3 million years, the Earth would have been pushed into a snowball Earth system. Complete glaciation. We were very close at that time. If that would have happened, we would not sit here, of course, today. Yeah? And But nature did a fantastic job of extracting CO2 from the atmosphere. We would have to replay it, but in a deliberate way today, by turning cities, infrastructures into organic mass. Okay, we had a number of initiatives, Bauhaus Earth, which we created in Germany. Of course, the new European Bauhaus, announced by the President of the European Union in her State of the Union speech. And we have the original Bauhaus. And why is the Bauhaus a good metaphor for this approach? Because it was meant to be, now in German, a Gesamtkunstwerk. You see, a composition of all capacities, knowledge, science, architecture, design, urban planning, art, to look at a holistic solution of a problem. What was the problem at the time in 1919, after the destruction of the First World War? It was to provide living space, accommodation, not just for the elite, but for ordinary people. And they turned to serial production, prefabrication, all these things, and using the industrial opportunities of that time. Today, the challenge is even bigger. We have a much higher population, we have much higher needs, and we have all the sustainability crisis. So we need a holistic approach, actually. So we need to think of the Bauhaus, but we have to think in completely different terms today. And we have other technical opportunities. This is also important. Just think for a second, what if CO2 was not a greenhouse gas? When we would have no climate problem. But would the built environment be sustainable? Would it be inclusive? Would it be beautiful? The answer is probably no, even if the climate crisis would not exist. But we have to make the built environment, which is the defining factor of every civilization and culture, have to make it inclusive and beautiful as well. And this is what Ursula von der Leyen always emphasizes when she talks about the new European Bauhaus. Now I'll show you why we have to tackle this problem, because otherwise our civilization will end. So let me see. This is an animation which I stole from The Guardian, from the website, and it shows you the emergence of the big cities of the world. The first flash was actually Eridu. You probably have never heard about it. That was built 6,000 years ago in Mesopotamia, the first real city in the world. And then you will see, if you look, so Babylon will flash up, Mykene, Knossos, Memphis in Egypt. You see, it's all in the Middle East, a few in China, India, nothing in the Americas, but will come a little bit later. If you look at, here we go in Mexico, you have the first cities. Rome comes into being when we move into the Roman era, and cities are spreading across southern Europe in the Mediterranean. You see a few added in India, still in Latin America. Now the Inca culture comes into being, for example. Now we are in the Dark Ages. Nothing happens, very little happens. And when we move towards the medieval climate optimum, as we call it, around the year 2000, you see cities are thriving in Europe in particular, also in the Far East. When we have the big plague, the Black Death in 1347, so there was a stagnation. And now we are moving into the industrial era. And you see cities are being added, and now it explodes. This is the Anthropocene. And you see, this is such a tremendous intervention with the natural metabolism of the earth, that we have to manage it. We have to confine it. We have to transform it into a sustainable project, actually. And if we are not able to do this, everything will be lost. How could we create a good Anthropocene? Because now we use the metaphor always in a negative sense. There can be a good Anthropocene. It means we should move from dumb, linear petroeconomy to what we might call smart circular bioeconomy. And the bioeconomy Joachim von Braun here has been a champion of the bioeconomy in Germany, for example, and worldwide. So this is just a chart, sort of figure how you could think of bioeconomy. It should be digital, of course. And by the way, Mark Palaio is here, has sort of hinted to, but if you go into the bioeconomy, when all the capital stocks on this planet will be reevaluated. So Qatar, for example, which has access to one of the biggest gas fields in the world, the capital will be lost completely. It's a stranded asset. While the Congo, for example, has probably the biggest bioresources in the world, it will become a very, very rich country in the bioeconomy. So you have a revaluation of all the capital stocks if we go into that transformation. So my final remarks are the following. I wasted some years of my youth on working on the foundations of quantum mechanics, and we tried to find out whether you can process information with a quantum computer without using any energy. And the answer is yes, you can. But anyway, with the quantum computing, the digitalization will have another great acceleration. And whether we build the first practical quantum computers, now Francesca is listening very well. If we will build the first quantum computer, the practical one, in 10 years or 15 years or 20 years, it doesn't matter. It will boost our digital tools and our digital capacities by a factor of 1 million at least. And everything we dream about with computing will be changed and transformed. So you see, we have this absolutely top, high-tech capacity. And at the same time, we have to preserve the living conditions of humanity on this planet, which is all natural. So we have to bring together high-tech and no-tech. And that's what we discussed in our charter about the re-entanglement, civilization and nature. And this may be the next step of the Anthropocene, the cyberorganic age, where cybernetics, computing, and so on is mixed in a harmonic way, actually in a harmonious way with nature, with natural solution, nature-based solution. So it might look like this. And Vicente Valla, who is here, who was the chief architect of Barcelona, which Francesca knows very well, of course, because you were one of the leading people in developing Barcelona, of course, and the digitalization and everything. He's, for example, creating cities that are, in a way, nature combined, entangled with technology. Yeah? This is how the future will look like, or at least it shall look like. And it is high-tech meets no-tech in this case. And we have tried to capture this in the charter we have proposed, and which we ask you to sign if you think it is the right message. Actually, it's called the Re-entanglement, a charter for the city and the earth. And now, why have we used the subtitle? Because the city and earth, that is, will be at all be the traditional message of the Pope to the world, actually. So thank you very much for listening.